Okay, so welcome to the September 2025 Cascade Mycological Society public meeting with an invited speaker. We're pleased today that, yes, we are. We're pleased today to have one of our own, Sandy Patton, former board member and current head of our IT department, keeps the website going, gets the e-news out on time, and most importantly, coordinates the field trips. So when you do that online applying for the field trip, this is the person who makes sure you get on there. Thank you for everything you do, and we're pleased to have Sandy speak to us tonight on what we know about fungi. It's an introductory talk on fungi. Give a warm welcome to Sandy Patton.
Hello, and thank you for the warm welcome. I hope everyone in the back of the room can hear me. You will notice that I'm seated at a table because I wanted to have my notes for this talk handy. The original title of this presentation was actually Fun Fungal Facts, and Ron, who is the entertaining half of this team, gave this talk at Eugene Nerd Night last month. So when Chris mentioned at the board meeting that we did not yet have a September speaker, I said I would ask Ron if he would give this talk. It's obvious how that turned out. Ron said he would be glad to attend and cheer me on, but the presentation part was all me. So what do we know about fungi? When I asked myself that question, a quote did come to mind. It is perhaps one that many of you have heard before. It's a bit of a tongue twister, but I'll give it a go. There are known knowns. These are things we know that we know. There are known unknowns. That is to say, there are things that we know we don't know, but there are also unknown unknowns. There are things we don't know we don't know. Well, I don't know that I was very satisfied with this somewhat bizarre statement coming from the then Secretary of Defense Donald Rumsfeld when asked about the state of the Iraq War. But I do think this statement is appropriate for a discussion on what we know about fungi. This is because the more we learn about fungi, the more we understand just how little we know. So let's start from the beginning. We do know that fungi have been around a long time. We're not really sure whether it's been millions or billions of years, but it is pretty much recognized that it's fungi that was responsible for helping aquatic plants to migrate onto land through a symbiotic relationship, and that relationship still exists today. So what is in the fungal kingdom of fungi? First, I will tell you, this is a lobster mushroom. That is an AI lobster mushroom, an AI generated lobster mushroom, which I thought was pretty comical. So I had to include it. But the kingdom of fungi, in addition to mushrooms, includes molds, rusts, mutts, mildew, and lichen. And all of those belonged in the plant kingdom up until 1969. What changed that is some realizations. If we look at plants, they contain chlorophyll and they create their own food. That's what they're well known for, is creating their own food via photosynthesis. Anyway, and their cell walls are made of cellulose. Not a whole lot in common with fungi. If you look at animals, neither of them, fungi and animals, neither of them have chlorophyll. They both consume other organisms. Animals actually, eat organisms and other ornaments and digest them inside their body. Whereas fungi actually exudes enzymes which break down the organism and then they absorb it. So it's actually kind of digested outside of the fungi. But they both absorb other organisms rather than creating their own food. The cell walls of fungi are made of chitin, not all animals, but it's certainly true for insects and crustaceans and some mollusks. And fungi and animals also share some key genetic features. What are all these people doing here? Anyway, so let's move on. We're going to do a fun little comparison between humans and fungi, although it's a little bit of a different comparison. This is Ötzi the Iceman. He was discovered in the Alps of Austria, I believe. It was, pardon me?
It was Italy. Well,
Italy. Oh, yeah, you're right. It was Italy. You're right. It was. I'm sorry. We went to Austria and Italy at the same time. I'm confusing myself. Okay. So anyway, he was discovered in the Alps, basically kind of freeze dried, and it was thought that he was 5,000 years old. When he was discovered, he was dead. Fun fact, he did have 2 mushrooms on his body when he was discovered. But he was dead and his status is still dead. That doesn't look very good. Sorry about that. Not sure. Might be, anyway, that is a lot smaller than it should be. Anyway, that is a picture of a split gill mushroom. And this actually, the spore was found in a core sample that was taken 1.5 miles below the ocean floor off the coast of Japan in 2012. They actually found 69 fungi in that core sample. They were able to take those 69, I assume they were spores, and try to cultivate them. And one of them actually created mycelium and fruited a mushroom. And that core sample was thought to be millions of years old. So I think they're much more resilient. Fungi is much more resilient than humans. And I hope this doesn't happen elsewhere in this presentation. Okay, so the human body's pretty amazing. It has over 200 cell types. When it comes to fungi, 1 cell type. We have single-celled yeast, and then we have a single cell that a spore is made of, and that spore has everything in it to create mycelium. And then that mycelium, you can see in this picture here, the mycelium can become the hypha. It starts as a spore that changed to hypha, which becomes hyphae. Is that right? Hyphae? Yes. And that becomes mycelium, and you can get a primordium, and then you can get an entire fruit reproductive structure called a mushroom. And we all know those mushrooms have lots of different parts to them, and mushrooms can be all different shapes and sizes, all from a single cell type. That's pretty amazing. So we all live here in Oregon. Is there anybody in this room who doesn't know about the humongous fungus? Hopefully not. It's out in Eastern Oregon in the Mount Hero National Forest, and it is known to be the largest living organism on Earth and covers 3.7 square miles. Oh, you're holding something up. Oh, a honey mushroom. Oh, thank you. Great. Oh, great, great. Well, the honey mushroom is the scientific name is Armillaria astoya. The common name is honey mushroom. It is edible when fully cooked, although as with all mushrooms, that's one of the things. Ron and I actually teach a beginning mushroom class next week, and he drills it into my head. There's 2 things when you're talking about fungi that should never enter your vocabulary, always and never. There's no such thing when it comes to mushrooms or fungi. So anyway, especially when it comes to edible fungi, anybody can be allergic to any mushroom. So always keep that in mind when it comes to edible fungi. So the honey mushroom can be both parasitic and saprophytic. Parasitic is basically how there's 3 types of mushroom, ecological types or the way they live, and that's parasitic, saprophytic, and mycorrhizal. So parasitic fungi, they attack living things, which can be an animal or plant. In this case, it's a tree. Then once the tree starts dying, it can continue. It actually transforms to a saprophytic form and continues to digest that tree. Fungi that can do both are called facultative saprophytes. Now, how many people, a lot of people, how many people have seen mycelium here? A few, great. How many people have seen a rhizomorph? All right, not quite as many hands. So, huh?
I've only seen them, so I couldn't believe it.
Oh, they're so cool. Actually, that is my hand holding a rhizomorph. I should have brought it with me. Didn't think about it. But anyway, rhizomorphs. So we're talking about all the different things that this one cell type can do. If you have a mycelial mat and they run out of food, it will create, all of a sudden it will say, oh, I can't find anything here. I need to go out and find something else. And what it does is create this thing called a rhizomorph, which really looks more like kind of a root structure. But it has a hollow tube inside. As that rhizomorph is growing out, which can go up to 100 feet, the mycelial mat is sending nutrients down that hollow tube to the end tip of that rhizomorph to keep it growing. Once it grows out and it finds more food to consume, it will actually, those end tips, the specialized end tips will convert back to mycelium and start growing as mycelium and consuming whatever it found and start sending those nutrients back to the main fungal organism. Pretty cool, in my opinion. So if you're ever out in the woods, if you look around, sometimes you can find these rhizomorphs. So this is something that this is my new thing. We have a humongous fungus. So I thought, well, why not a tiny mungus fungus? We're pretty well known for our Douglas fir trees. And we do have a mushroom that lives exclusively in a Douglas fir. That's its whole, the cone of a Douglas fir is its whole existence. They believe it actually starts as an endophytic fungi, and we'll talk a little bit more about that later. But that's a fungi that lives in the tissue of plants. So it's thought that when these cones are up on the trees, they're just living, the fungi is just living in those cones. And then when it drops and it starts raining and decaying a little bit, then the mushroom starts fruiting out of it. So that's our tiny mungus fungus.
We have an example.
We have an example. Great, great. So this is the smallest mushroom that has been found on Earth. And no, it doesn't grow in Oregon, but I just thought it was so darn cute that I had to include it. And I'm sure I've got something interesting to say about it. Actually, it was found in Taiwan. Let me see. It was found in Taiwan. And let me see, it's almost very mushroom. Oh, in 2019. Oh, and there's now 23 observations of it on iNaturalist, which includes 4 in Australia. But finding a mushroom that's only 1 millimeter high is probably pretty difficult. Now, this mushroom, on the other hand, is very easy to find, although you're not going to find it around here either because it's more tropical, grows in more tropical environments. Most mushrooms fruit at between 50 and 65 degrees. But this is a tropical mushroom, so it's in Florida and Central and South America. That cap is typically about 20 inches across, but can grow up to 40 inches across. And it is edible. So where do we find fungi? We all know that answer. It's everywhere. So let's start in the soil. Many of you have probably read, maybe you've read a book called Mycelium Running, or you've heard Paul Stamets talk, and he often talks about the fact that 1 cubic inch of topsoil can contain up to 8 miles of mycelium. Okay, if you take all those fungal strands together. Now that's probably true for topsoil that's in the forest. But once we start tilling and disturbing and adding chemicals to soil, the fungi are definitely going to diminish. I mentioned those endophytic fungi in those cones. Well, that's what you will find in every living plant. If you look at every plant, all the leaves on every single tree are full of endophytic fungi. Endophytic fungi. I had a great epiphany today. It's like, oh, we can just take a branch of a Douglas fir tree full of needles, put it on the mushroom display, and we can add 46 fungi. Although those are not mushrooms, so I guess it wouldn't count. But anyway, so the needles of a Douglas fir tree have 46 species of fungi in them. And there's not a whole lot of trees that they've evaluated so far, but that just tells you there's so many things to learn. So fungi, actually they have the helper of bacteria. Those are considered nature's recyclers. If it weren't for fungi and bacteria in the forest, we would just have piles of debris of wood and leaves. Some fungi break down leaves, some break down softwood or hardwood, some specialize in different things. But if it weren't for fungi, we would just have miles of debris. Fungi exist in extreme heat. Most fungi fruit between 50 and 65 degrees, whereas the tropical fungi prefer 70 to 80 degrees. But there's something called thermophilic fungi that like to fruit in temperatures over 113 degrees. So yes, you can go to the desert and find fungi. And of course, we have the opposite. Psychrophilic fungi enjoy the extreme cold. They grow in the Arctic within glaciers and the permafrost up in Siberia. But we do have one in Oregon. This is what they call ice fungi, the ice mushrooms. It's called the psychrophilic, psychrophilic mushrooms. Okay, this mushroom is called Molly, can I pronounce it? Exidioopsis ephysa. Exidioopsis exifa.
Wow.
And what it does is it takes ice that forms on dead wood and turns it into these fine strands called ice hair. I haven't seen it, but it's on iNaturalist. It can be found in Oregon in the winter. So time to go out and look for it. Pretty cool. Other extreme conditions that fungi exist is in radioactive environment. There's over 200 species of fungi that can actually live off of radioactive material. There's also a fungus that's considered to be more of a pest fungus that shows up in fuel lines and fuel tanks, which can cause a problem, but that's where they like to live. Of course, we have underwater fungi. There's actually been over 2,200 aquatic fungi described and named so far. One of those was actually discovered right here in Oregon. I see Molly smiling because she remembers that.
Because when the guy did it,
Uh-huh,
and he took pictures,
right.
Chris and my mom, he had the pictures in his jacket. And he went on a tour with us and he went and said all the.
Oh, that's right. He told you, you were the first one he told about it, right?
So.
Oh, yes, Molly. I remember, I knew we had a connection to that. That's so cool. Yep. So it was found in the Rogue River in 2005, and it was aptly named Satharella aquatica in 2010. And of course, fungi's in the air. We are all breathing fungi spores right now. It's estimated we breathe in at least 100,000 spores every single day. Luckily, most all of us don't have an issue with it. But I have talked to people that work in a closed environment of, mushroom growing. And if you get a high concentration of them, they can definitely cause a problem. I've even heard Noah Siegel complain that he has definitely inhaled more than his fair share of fungal spores while doing identifications. And of course, they're on our skin and in our bodies. These can show up as fungal infections, which are not good. But there's also that gut biome, what we can call the microbiome, that's very positive, that helps us digest and absorb, digest food and absorb nutrients. So, and of course, we have mushrooms in space. Now, they weren't naturally there. The first mushrooms that went to space were actually lichens that survived 18 months attached to the outside of the International Space Station. More recently, actually in April of 2025, there was Mission Mushroom that was launched on SpaceX, and they successfully fruited oyster mushrooms in orbit. So how are we using fungi? Mostly why would that okay not go away? In sustainable products and solutions. One of the first things that they started using, and a lot of this comes not from mushrooms, but actually from the mycelium. And they're making lots of products out of that. One of the first ones was packaging. And that started up in 2007 in a private research university in upstate New York. Two students, this was their school project. And those two students ended up developing a product for packaging as a styrofoam replacement for packaging materials. That company is now Evocative Design, that has over 120 employees, and it has major contracts with companies like IKEA, Puma, and Dell. They're also using that mycelium foam as the core for surfboards and also in buoys. No, you can't. Sorry. But it is it's better. I mean, at least it's not being made from fossil fuels, which is what plastic comes from. And it's all biodegradable, so much better. It's also being used in building materials. That started in about 2009, but primarily with insulation and acoustic panels. But they also have mycelium bricks, which haven't been used a whole lot, but they've recently made some innovations which will allow them to have the strength and durability to actually be used in constructing both interior and exterior walls of buildings. So hopefully we can all live in a mushroom house, a mycelium house one day. Mycelium is very popular when it comes to clothing and mycelium leather. That started out in, let me see, I want to say 2013. Yes, 2013. And has been very popular. A lot of these are high-end products and pretty expensive, but they're very nice. There is a company called MycoWorks that has now patented a process that allows them to create leather from reishi mycelia, the reishi mushroom, the mycelium of the reishi, that during the manufacturing process, they can customize it to a specific thickness, strength, and texture. So that's pretty cool. obviously it's been, if anybody gets to see him, he knows Ron loves to talk about the fact that we have lots of fungi within our garden. It's very helpful to soil, and any farmers in the ecologically minded farmers are working to promote that fungal health to help build their soil and improve their plants. And of course, we have plastic-eating fungi.
Thank goodness.
That's a lot of this is still in the research stages. Just this last year, there was a Kickstarter project to develop myco-digestible diapers. Now, the diapers do not digest themselves. What they do is they create diapers, and they include a fungal packet that you can put in with your diapers when you throw them away, so that they will start decomposing within a couple of weeks. And yes, we still have micro remediation that has been around for quite a long time. And they are still using it. And the latest project is one to hopefully remediate PFAS forever chemicals out of the environment. Fungi is used in all kinds of health aspects. Lots of medicines are derived from fungi, the most famous one being penicillin. They've actually recently discovered isolated 72 different mechanisms or chemicals or something from fungi, from aquatic fungi, that they believe are potential antibiotics. But mushrooms are being explored in lots of different ways. All kinds of fungi are now being tested for their medicinal properties. And hopefully we're going to help make some progress in the subject on the areas of cancer to help solve that. If any of you are non-meat eaters like Ron and I, hopefully you know that mushrooms are nutritional powerhouses. And Ron likes to tell people this, is that the protein that's in meat is not something that is very body friendly. You actually have to ingest that protein and break it all down into individual amino acids, and then build them all back up in order for your body to use that protein. Whereas the mushrooms have all the amino acids to build protein, and it's very body friendly. They also contain tons of vitamins and minerals and antioxidants. And skincare. This is something that I just recently learned about, is that a lot of skincare companies are starting to use fungi within their products. I don't see anti-wrinkle in there, so I don't know that I'll be getting it, but anyway, anti-aging, that's probably anti-wrinkle. So lots of different products are being used in that industry. And of course, this is an area that we really enjoy, is eating fungi in the form of mushrooms. Most everybody in this room, I'm sure, eats mushrooms, hopefully. And they're also being used in vegan products. But the biggest contributor of mushrooms or fungi in our food and beverage products is actually that single-celled yeast. It's responsible for all the fermented products like bread and cheese and all of those beverages that we really enjoy, like beer and wine and distilled beverages. All are a result of yeast. So mushrooms produce vitamin D just like humans. So you can either go outside and soak up that sun and get a sunburn to get your vitamin D, or you can put your mushrooms outside. They can soak up that vitamin D, and you can eat those mushrooms and get all the vitamin D you need. But you need to put them outside for about 20 minutes at least in order to get that vitamin D for you, for your body. Oh, that's true. They can be dry. Yeah. Just hang them out there. So we also have mushrooms that glow in the dark, excuse me. There's actually 125 species worldwide that do that. We have one here in Oregon This is what it looks like when it's alive and in the daytime, not glowing. I'm not sure if that is a jack-o'-lantern or not, that one, but anyway, pardon me? Jack-o'-lantern, no, that is not edible. I don't think so. Now, we talked about that honey mushroom out in Eastern Oregon, which is edible, and it glows also, but it's not the mushroom that glows, it's the mycelium that glows. So, fungi can also help us determine whether we have good air quality in our neighborhood. So everybody needs to go home, look around their neighborhood, and a lot of people are bothered by this stuff that looks all bushy on that's growing all over their trees. Well, that's lichen. And if you have that really shrubby looking lichen growing on your trees, that's a good thing. That means you have healthy air. If you have no lichen in your neighborhood, pardon me? No, move, that's a good idea. So the shrubby lichen is the most sensitive to pollution in the air, whereas the crusty lichen, there's three different forms of lichen. The crusty lichen is the most tolerant. And that's kind of that stuff that you just, those little patches of stuff that you see, those little spots that you see on your driveway and on the sidewalks, that's lichen. So if you only have that and you don't see any of the other shrubby stuff, then your air quality might need to be looked at. Actually, there was a story of this in the news. I first learned about this, I think it was 5 to 7 years ago, up in Portland. They noticed this one industrial area of Portland that had no lichen. And it was actually a botanist that noticed it. And they started looking into it. And it was the pollutants from a glass factory that was killing all the lichens. So that glass factory was actually shut down for that. So hopefully we all remember actually, I thought it was 7th grade sciences, but AI told me it's actually, they're teaching how to make rain in kindergarten now. That's pretty amazing. Anyway, so we all know that mushrooms love rain, and luckily they help us because in order to get rain, you need to have these microscopic particles in the air that water vapor forms around to create the droplets. Well, a lot of those particles are actually mushroom spores. So they help us out with creating rain. They can also create wind. Well, I think that's kind of a little stretch. But some mushrooms do create small air currents enough to whisk those spores a little bit farther away from them. So they can create their own air currents. Oh, breakthrough asphalt. This one's cool. Hopefully a lot of you know maybe some of you know what Coprinus comatus is. The common name is shaggy mane, which is an edible mushroom that grows in our area. It can actually grow up through asphalt. I mean, it is the most delicate. At the mushroom festival, we actually store it in a jar of water. That's how delicate this mushroom is. Despite that, it can come up through asphalt, believe it or not. I haven't seen it yet, but we have lots of shaggy mane in this area, and we have some not so good roads. So still have hope that I'll one day see it. Wrecked trains? Are you kidding me? Yes, it can happen. Hasn't happened lately, but when they were building the railroads and out across the U.S., there's a mushroom that was given the name of the train wrecker because it likes to grow on railroad ties. That creosote stuff that they put all over those railroad ties did not phase it a bit. So those railroad ties would degrade. As a result, the railroad tracks would shift and trains would derail. They have since added fungicides to that creosote so that to no longer happen. But that's how we got the name of the train wrecker mushroom. Oh, we now have fungi wash genes rather than stone wash genes. Actually, I think I'm of the age where I don't have a whole lot of appreciation for buying new things that look old. I'll be glad to go to the thrift store and buy something that looks old because it is old. But anyway, the faded look jeans are very popular, and they used to do this with pumice stones, and that would really just do a lot of damage to the fabric, plus ruin the machines that they were doing it with. Whereas now they use fungi, the enzymes that are produced from fungi, and it only degrades the outer layer so of the cotton fiber, so it doesn't cause as much damage to the actual jeans. We also have bio batteries. This is pretty amazing. They are now starting to, this is actually a 3D printed living battery. You don't charge it, you feed it. You actually can store this in a dry package. And then when you need to use it, you add water and whatever it needs to eat. I guess it comes with something. And it's obviously not going to be powering our homes or our cars anytime soon, but it can be used in for a limited time period to power like a sensor or something like that in a remote location. And the really good thing is it can be stored. It's really small. It can be stored very easily until you need it. Then you just add water. And then when you're done with it, it actually consumes itself from the inside out. Pretty amazing. And yes, there's more. We actually may see fungi in lithium cell batteries pretty soon to help make them more sustainable and also increase the power. And they're also looking at the electrical pulses in fungi that fungi can create. And there is I think it's called the Unconventional Computing Lab in the UK is looking into creating biological computers with fungi. So something else that's going on. So there's so much that we do not know. Scientists estimate that we've discovered only a small fraction of fungal species out there. And fungi, there's so many aspects of fungi that we don't know about. Their diversity, their interaction, and their potential uses are still largely unknown. The good news, if anybody's seen this graphic before, is these are all companies that deal with fungi. And we all know that nothing happens unless somebody's making money off of it. So luckily, a lot of small research projects, I'm sure all of these started as small research projects somewhere. And now they're getting to be larger companies. And so it's just kind of like a mycelial net of fungi-related companies that have sprung up a lot around the world. And we'll hopefully keep that research keep going. So if you want to learn more, as I said in my bio, Ron and I do the newsletter for CMS, and part of that is I also post to Facebook for the Mushroom Club. And so a lot of those stories, I just have an alert, a Google alert that I do, that I get emails whenever something is new about fungi. And then there's 2 newsletters that I subscribe to, and that's Myco Stories, which actually comes out daily, sometimes multiple times a day with stories about fungi. And then there's one called Micropreneur, which is basically just about industry that's using fungi and what they're doing. So those are QR codes if you want to get to those websites. You want to turn on the lights? I don't know if anybody wants to do that, or you can just. And there's also our website, probably not quite as educational, but we do have fun fungal facts and some word games and things like that for kids on our website.
Lots of links to science, lots of links.
Oh, yes, there is.
To create a website.
Thank you, thank you, thank you. So I stretched it to 40 minutes. You did 20 minutes, so I doubled it. So not too bad. Does anybody have questions? I don't know that I have the answers. That wasn't as bad as I thought.
Yes.
I can always edit it. Any questions that I may not know an answer to, but maybe somebody will?
So much of your approach was so novel that I'm just like, what, really?
Yeah, well, it is, you can just, and we've actually, Ron, I don't know if you noticed in the last newsletter, Ron has gotten into AI imaging.
Yeah.
Which is kind of fun. But yeah, I mean, it is pretty amazing. I have to admit that I knew all of these things were going on, but I did a little bit more research to try to put this together. It's a presentation that I've been wanting to put together for a time, so it happened.
Good.
Didn't know I'd have to give it, but that's okay. So hopefully everybody learns something. You have a question?
It expanded my awareness of mushrooms and so I wasn't even aware of some of this. There is one thing I talked about how it uses or can create electrical current.
Electrical currents, yes.
It says that it's being used in a biological computer. I've never heard of them, so.
Okay. Well, actually, I think it might be in my backup slides. Let me see. Oh, actually. I wasn't sure. Where's my remove slides? Oh, that was actually a remove slide. Oh, this is where you find that humongous fungus. If anybody wants to know.
No, but I've been in lots of forests with honey mushrooms.
Oh, right.
Dead trees around honey mushrooms.
Yeah, we went out last year. Yeah.
2 years.
Was it 2 years ago? Yeah, we drove out to Boise. So on the way back, we did go try to find us. That's our car on that slide. Going into that area and trying to find. We found mycelium and we found dead trees. Mycelium and dead trees mostly. Yeah. Well, I guess it fruits in the fall. We weren't in the fall. We weren't there in the fall. So we were in the springtime. Anyway.
We had around here. I went to see our car and then
Lots of stuff that I deleted. Let me see. I know I had something on biocomputers in here. Oh, okay. So this was, it's funny because I thought, who in the heck would put this together? But it was actually the head of the alternative computing lab or whatever it was called. He actually just put a bunch of stuff on a breadboard and said, oh, this is our biocomputer. It's like, I don't think that's going to cut it in my book. But anyway, there is, this is my AI generated version of a biocomputer. Yeah, but there is a presentation out there on the web from the Unconventional Computing Lab in Bristol. And it's about the future of fungal computers. And they actually do. So far, I did watch this, and so far what they're doing is actually they're plugging diodes? Is that what they would be? Diodes into fungus, all kinds of different fungus, and taking those electrical spikes and reading them. And they actually, if you listen to this, they have compared those fungal spikes to human languages and believe there's very much a similar pattern.
They're talking to us.
No, well, I hope, I don't know. I think they're much smarter than us, so They're talking to each other at this point. When they're talking about biological computers, I think it's more about just trying to understand the biology of fungi and how they're talking to each other. But there was something that Ron was looking online, but that was fluid dynamics, right?
It's how
Um,
they can communicate within themselves.
Right.
They either communicate through hormones or other chemicals going through the mycelium, or they can do pulsing. And the pressure that it creates is also communicating, or they can do electrical pulses. So all those are different forms of communicating within a mycelium network. What they're saying and what it means and the responses to it, nobody knows.
Well, but it is also a situation, if anybody, we actually worked in the computer industry, and a computer is just a binary machine that knows on and off. So electrical pulse on and off can actually become a computer. So that's what the thinking is that eventually, if we understand them well enough, we may be able to make biological computers. Probably not in my lifetime, but maybe in another lifetime.
There
Go ahead.
was an article in the Smithsonian magazine several years ago that the trees are talking to each other.
Oh, definitely. Yes, they,
So
oh, right. Yes. No, they do believe there's some kind of chemical signal. There's something going on. There's something going on when, and they basically, simulated that by attacking a tree.
They simulated how do I need that?
Oh, the computer people.
Okay. They simulated like an insect attack on a particular tree. That tree created hormones to try and other chemicals to ward off the attack. Those chemicals went through the mycelium network that it's attached to, went to other trees, and other trees created what they call a sympathetic reaction and started producing those same exact chemicals. So it was, I don't know if that type of communication was like, hey, Bob's getting attacked, let's get ready for it. I think there was just something that happened automatically. It's like if you're in an area where everybody's laughing, you'll probably start laughing. You don't know why.
Lions start screaming.
Right, you're gonna scream.
Right, exactly. So it's just one of those things that they call it a sympathetic reaction. But yeah, these messaging chemicals and stuff travel through the mycelium network, came into the other trees that absorbed it in and started doing the same thing. So.
Any other questions or comment?
I was expanding uses. Being that they packages, certain folks and everything. How do they harvest or create that much mycelium?
Okay, so the question is, how are they creating all that mycelium to do that packaging? They are creating huge manufacturing companies, and all of it gets created in big sheets, I assume. If you go online, and I'm trying to think of, right, well, that's one thing, is they can, when you can either create it in sheets, but that's what's cool about them, is that they can, if you take, like, if you want to create a cement mushroom, you create a mold that looks like a mushroom, and then you pour cement in it. Well, you can do the same thing with mushrooms, and you can put everything that a mushroom needs to grow inside a mold and inoculate it with spores, and it will grow in that form. So that's one thing that's good about it, is that it can be grown in any shape or form that you can create a mold for. So you can just do it in sheets, like in leather. They have this manufacturing process where they can control the thickness of how thick that mycelium grows to create that leather. And it's all just, innovations in manufacturing. The biggest impediment, I guess, to a lot of fungi right now is just upscaling whatever they've done so many things on a small scale. Now they're trying to do them on a larger scales. But yes, they're now creating warehouse size buildings in order to manufacture myco-based products. Oops. Yes, question.
From spores and mold, and if there's any, is there any here?
Oh, I'm going to repeat it. Okay. About sickness from mold, right? Mold in a house or mold anywhere. Yeah. Right. Yeah. Oh.
And, on the search that, something else, understand why that happened, so.
Do you know something, Chris? Chris knows something. Maybe.
With global temperatures and ever increasing. Up until recently, as Sandy mentioned twice during her talk, most fungi exist and grow and form mushrooms or fruiting bodies in that 50 to 65 degree Fahrenheit range. And everybody knows our internal body temperature is much hotter than that. But she did mention some fungi that really like warmer temperatures in the tropics. And yes. And it's those types of heat resistant fungi that are now becoming more concern in human health. So we've always had aspergillus species in our environment, but now what we're and other molds in our home environments. But now what we're finding is the combination of really tightly built houses and more higher temperature resistant fungi are kind of on a collision course with human health. And there are things like, I forget the genus name of the valley fever fungus that's prevalent in certain desert areas of California. It's becomes a lung infection and it's pretty virulent. Anything that is used within humans to kill fungi is so like they're like the same toxic chemicals they use for fighting cancer. So they're basically subverting your immune system to kill the fungi infection within your body. So when a human does get a fungal disease, it's a really huge health crisis. But we'll be seeing more and more of it as temperatures increase. And just the heat exposure to humans, I just saw a scientific piece today where just tropical storms, where they say, the average tropical storm that goes through North America kills about 24 people. Well, extended research says it's more like 12,000 people are affected by the loss of air conditioning, clean water, and the subsequent infections that come with a tropical storm. So these are ancillary effects to global warming, and we're seeing it day to day in fungi out in the environment. There's a lot less of it and different ones we're seeing.
It wasn't on, was it? I couldn't hear any microscope.
No, this is for the computer that goes into the live stream.
So that was the other thing,
That's what
human
it's
body
for.
temperature going down.
Yes, yes.
Yeah, there's a lot of that's been happening, well, especially in the East Coast where the tropical storms and things like that and floods. They're getting a lot of that mold that's starting, well, it's been going on for a while now with the black molds that are affecting the lungs and everything of humans and animals.
Okay, yeah, I was gonna say Debbie Downer here. I mean, this is supposed to be about good stuff about fungi. Just kidding. No, but I tell you, I don't know. Ron and I moved here to garden, and then we discovered mushrooms. Believe me, if you would have told me my entire retirement life would be consumed with mushrooms, I would have said, "What are you talking about?" It's like what? But I don't know. Some people just, join the club. They go out and learn how to find chanterelles. And then that's it. They're happy. But there is so much more to learn about mushrooms. Every single day, about fungi, just, you know, we always say mushrooms, but it's really fungi because it's so big. So just all kinds of fascinating things going on.
Mine's invaded by the mushroom.
Yes, I have. I've been invaded by the mushroom.
It's
The mushroom,
it can be
mushroom fever.
It can be.
Maybe that's it.
Consuming of. Speaking of, my wife Molly and I and Lee and Susan and some other folks here, Claire, went on a field trip yesterday and brought back some samples of what we found on the coast yesterday. People would like to come up and take a look.
Oh, I don't know if
Always
anybody.
put some names on some of them. And are you available for questions?
Sure, if anybody wants to. And other people here can sure do that too.
Hope nobody online wanted questions because I wasn't paying attention. I'm usually doing that.
Yeah, sorry, I was so excited about what.